Hi everyone, Miss Andronicus here, and today we are looking at prisms and cylinders. Volume of prisms can be thought about in a couple of different ways. You've got area of base times height, or area of the cross-section times length. Let me show you what I mean. Have a look at this selection of shapes. If we take that cylinder and we cut it in half across the middle there, you can see that it forms a shape. It cuts it in two different halves, and that exposed face is what we call the cross-section. You'll notice it's a circle. It's exactly the same as that base shape anyway. Same thing with this triangular prism. If you cut it, it will form a cross-section, which is exactly the same face as the one on the end. So these cross-sections in prisms match that face at the bottom. So that's why we can think of this formula as area of that cross-section times the length, which is area of this face multiplied by the length, or area of the base multiplied by that height, depending on the way that you stand it. Don't mind which way you think about it, as long as you know that you've got to get the area of whatever that face is on the end and multiply it by that third dimension. That means you need to know your formulae for areas of the 2D shape that you'll see on the end before you then just multiply it by that third dimension, which is the length. That's the easy bit. So you need to make sure that you know these formulas. These are very, very important. Let's have a look at this example. Okay, so if we were to get the volume of this shape, first of all, you need to figure out, well, what shape are we showing here? This shape is a trapezoidal prism. You can tell by the face at the end, or the base face, or the cross-sectional face, whatever you want to call it. That is your trapezium. As long as you get the area of that face first, you then need to multiply it by this 12, which is the height. Have a go at that now. The first step in working this out is to make sure that you get the formulae down. So that first section is the formula for the area of that trapezium on the end. So a plus b divided by 2 multiplied by the height. So that's your a, that's your b, and that's your height in this instance. Remember, we're considering that as a 2D shape only. I've got the L here for the length of the entire shape. And that's the complete working. So we worked out the face area, multiplied it by 12, and it's 312 centimeters cubed. Let's say it's centimeters, and remember it's volume, so it's always cubed. Let's try another example. Let's have a look at this cylinder. Remember, area of that face, that base face, or that cross-section. So we can see that cross-section is a circle. So you've got to get the area of the circle first. So let's get that formulae down, pi r squared, and then multiplying it by the height. Multiplying it by the height. Give that one a go. And there are the full workings there. Please don't get trapped with the fact that the diagram is saying 14 centimeters for the whole diameter, and we need to use the radius in our workings. Moving on to surface area. Surface area of a solid is found by adding the area of each face. So you need to think about laying that prism flat, getting the net of it, and then of course getting the area of each of those faces and adding them together. So think about that for this example that we had above. Please see if you can give it a go. You need to consider each of these faces individually. So surface area of a 3D shape can actually take quite a bit of time and effort and concentration. So number one, please make sure you give yourself a diagram, draw it out, label the sides. That is very, very important. Give it a go. Okay, let's go through this answer. I know this might seem quite intense, but I've tried to color code everything for you so that we can go through it carefully. As you can see over on the right, I've drawn a nice sketch of every single face and labeled it with each measurement. So for example, you've got the base faces there, or the cross sections there, the orange trapeziums on each end, labeled. So you've got A, B, and that height. You've got two of them. Okay, then the back side is the green side, the top is the yellow across the top, the slant side is this blue side here that you can see the most of, and of course the bottom is the largest side, that's the pink. Now, once I get my diagram and I can label and color code each of those sides, or I can number them even, side 1, side 2, that's fine, I then have to go through each one and get the area of each one. Now, the greatest thing with prisms is, as you can see, other than these base faces on each end, they are always joined by rectangles. So actually, getting the area of each face is really very easy because that formula is the easiest of all, length times width. And it's just a lot of length times width, provided that you have the correct measurements. So as you can see, I've started with just that green side, and then I go to the yellow, then I go to the blue, all the way through. So length times width, length times width, length times width all the way. And then I get those answers. If I keep going, again, length times width for that pink side, and then I get to the trapeziums. I've done that sum once, multiplied it by 2 because there were 2 of those trapeziums, and there's my answer. And I can clearly see from the colors that I haven't left anything out. Then my final task is, of course, I need to add everything together. So I take all of those measurements and I add them all together. This is very important because that is your final answer. This level of working, there's so many steps, it's so easy to miss something out or get it wrong, not be able to check it later. So it is very important that you do all the working step by step, space it out in your books one at a time, use your columns. This could take almost a whole column. So just be very aware that this level of working is very important, because if you do make an error, you can pick it up and then correct it as you go. Okay, one more example. Let's try this cylinder. Remember, surface area. How many surfaces does a cylinder have? Give it a go now. Okay, let's have a look. So once again, I've drawn a diagram. Firstly, I need to be aware that this curved surface here, this curved surface unravels to be a rectangle. But this length, as you can see from my diagram, is whatever the distance is around that circumference of the circle. So that's why I've written circumference of a circle here. Then I have 2 circles, and I've got that height there. So this is the trickiness with the cylinder, because, okay, you can get the area of a circle, that's the purple there, no problem, multiplied it by 2 because I have the top and the bottom of the shape. The green section though, firstly, I need to get the circumference of the circle first, then I use whatever that measurement is, and I then can get the area of that rectangle. So it's a little bit trickier because of that, but you've got to just be aware, are you using the radius, are you using the diameter, are you finding the area, are you finding the circumference, is it centimeters squared, is it centimeters, just straight centimeters because it's circumference. So you just need to be aware of that. Once you get those answers, then you add them together as you did for the other examples. That's it. There's a few steps, give it a go, you'll be fine. Good luck. Bye guys.